Let's look at this example to see how you can make calculations using molarity, percent by mass, mole fraction, and mole percent. In this example, a solution is prepared by dissolving 17.2 grams of ethylene glycol. So the molar mass of ethylene glycol is 62.07 grams. So this is in 0.500 kilogram of water. The final volume of the solution is 5.15 milliliters. So what I want us to do is to calculate the concentration of the solution in the following units. So calculate it using molarity, percent by mass, mole fraction, and mole percent. We will start our calculation with molarity. What is the molarity of this solution? So first, we know that molarity is given by number of moles per liter. That is mole divided by liter. So what we need to do is to determine how do we find the moles in this case, and how do we find the liters in this case. So the question is, where do we find the mole? The mole is going to come from the mass, the grams. We know that mole is given by the mass, so the mass in grams divided by the molar mass. So in this case, our mass is 17.2 grams. That is the mass of ethylene glycol, and the molar mass of ethylene glycol is 62.07 grams. So if I have to make a calculation on my calculator, 17.2 divided by 62.07. So the number of moles in this case is 0.277. So 0.277 mole. Once we find the number of moles, then we calculate the molarity of the solution. Now, what about the volume? Our volume, now we want to change our volume to liters, is given by 5 0.15 milliliters times 1 liter divided by 1000 milliliter. So that is our conversion factor. So if I can get rid of the multiplication sign and put an equals sign, so our volume is 0.515 liter. Now we know that, as we said, molarity is given by mole per liter. In this case, 0.277 mole divided by 0.515 liter. So the molarity of the solution is 0.277 divided by 0.515, which gives us 0.538. So 0.538 moles per liter. So this is our molarity. Now we go to the second phase, that is molarity. How do we determine molarity? So this is the one that we are dealing with. So molarity is given by the number of moles per kilogram. So number of moles of solute per kilogram of solvent. So in this case, we already know the number of moles of solute. If we can go back to our first answer, the number of moles of solute was 0.277 mole. Now the mass of solvent, in this case our solvent is water. So the mass is 0.500 kilogram of water. Now this one is really simple because we already had the number of moles. So if I make a calculation, .277 divided by 0.5. The molarity of the solution is 0.554 mole per kilogram. So this mole per kilogram is sometimes written as just small m. Don't confuse it with mass. So this is our answer for molarity. Now we move on to percent by mass. So that is C. Remember, our problem is a solution is prepared by dissolving 17.2 grams of ethylene glycol in 0.500 kilogram of water. So the final volume of the solution is 515 milliliters. So we are trying to make calculations. We found molarity, and we are determining percent by mass. So what is this percent by mass? So percent by mass is given by the mass of solute divided by mass of solute plus mass of solvent the answer we get times 100% because it is a percentage. In this case, our mass of solute is 17.2 grams of ethylene glycol, and we also still have the solute here, and the solvent, you need to change the mass from kilogram to grams, so it will be 500 grams. This, whatever we get here, times 100%. So if I have to make a calculation, 17.2 divided by times 100. So our percentage is 3.33%. So these answers, I'm making them to 3 significant figures. So this is our percentage by mass. Now let's look at the mole fraction. The mole fraction. Now, to determine the mole fraction, the mole fraction is given by the number of moles of solute divided by number of moles of solute plus number of moles of solvent. So what we are saying is the solute as a fraction of the total solution. But from our previous problem, we already know the number of moles of solute. We already know that it is 0.277 mole. So let me just get rid of something. So we already know that the solute has 0.277 moles. Now our solvent is water. So the number of moles of water in this case is the mass. We change the mass to grams, which is 500 grams of that water, divide by the molar mass of water, which is 18.02 grams. So this will tell us that we have 27.7 So we have 27.7 more of our solvent, which is water. Now, as we said, the mole fraction is number of moles of solute divided by number of moles of solute plus number of moles of solvent. So in this case, our mole fraction will be given by the number of moles of solute, which is 0.277, divided by the number of moles of solute, 0.277, plus the number of moles of solvent, which is water in this case. So if I have to do that calculation, I find that our mole fraction is 0.00990. So I'm still putting it to three significant figures. So this is our mole fraction. So mole fraction does not have units because the units more cancel each other. Now the last part, what is our mole percent? So the mole percent is given by the mole fraction times 100%. So mole fraction times 100%. So in this case, our mole fraction was 0.00990 times 100%, which gives us 0.990%. So this is our mole percent. So that's how we solve a problem like this one. So try to practice the problems in your handout. Just make sure that you understand them. Check this video again and again so that you get to know these problems. Thank you.